Dear students, next to Oswald dilution law, let me enter into common ion effect, very important effect, but very simple effect, common ion effect. It is just extension of Le Chatelier principle. So if you have studied Le Chatelier principle, if you have enjoyed Le Chatelier principle, you can very easily understand common ion effect. What is it? When a salt of weak acid or weak base, weak acid, let me take acetic acid, weak base, let me take ammonium hydroxide. When a salt of weak acid means weak acid with strong base sodium hydroxide. When this weak acid is neutralized by a strong base, you will be getting an acid, we will be getting a salt. H plus is neutralized by OH minus to give water and sodium acid. This is salt. This is salt. This is salt. Likewise, weak base can be neutralized by a strong acid, say hydrochloric acid, to get the salt, water and ammonium chloride. Ammonium chloride is the salt. So when a salt of a weak acid is added into the weak acid, what is happening? When the salt of weak base is added into this base, what is happening? That's discussed under common ion effect. Weak acid ionizes like this. Acetic acid ionizes to form acetate ion and hydrogen ion. Of course, with water, acetate ion and hydronium ion, both are accepted. I can write H plus or H2, H3O plus. If I write H3O plus, I have to write H2O here. That's all. It is ionization of weak acid. Now I am adding acetate ion into sodium acetate into it. It is a salt. But the salt is a strong electrolyte. It ionizes almost fully to give acetate ion and the sodium ion. Alright? If I add this into this solution, what is happening? Already there exists an equilibrium. Acetic acid get ionized to give acetate ion and hydrogen ion. Already it is in equilibrium. If I add sodium acetate, I am disturbing this equilibrium. How? I am adding one component which is common. What is that one common? Sodium ion is not present here. Acetate ion is present. It is common. Sodium acetate is not present here. It is not common. So this is not common, this is not common, this is common. When we add some ions, which is common to the ions available already in an equilibrium mixture, that equilibrium is being disturbed. This is being disturbed. How? As per Le Chatelier principle, if an equilibrium is disturbed in any way, the equilibrium will try to compensate the effect. How can it compensate the effect? Now we have increased the concentration of acetate ion, therefore the equilibrium will be shifted in the opposite direction. What we can assume and say, when a salt of weak acid is added into a weak acid, the ionization of weak acid is suppressed. The ionization of weak acid is suppressed due to common ion. That is common ion effect. When we add a common ion into a weak acid or weak base, the ionization is suppressed because the equilibrium shifted in the backward direction as per Le Chatelier principle. Likewise, if in the case of ammonium hydroxide, if I add ammonium ion, how can we say ammonium ion? It is a strong electrolyte, ionized fully to give ammonium ion, chloride ion. Common ion is ammonium ion. When a salt of weak base is added into ammonium hydroxide, the ionization is suppressed due to common ion effect. Why it is suppressed? The common ion is shifting the equilibrium in the backward direction. Therefore, dissociation is suppressed. That is known as common ion effect. The suppression in the dissociation of weak acid or weak base by the addition of common ion is known as common ion effect. Common ion in what we are adding? By the addition of a salt from the weak acid, salt of a weak base. So that is known as Kamaneyan effect. Thank you.